Peter, do you know how to draw a picture using the discrete Fourier transform?
Oh, yeah. I draw stuff all the time. Like when I drew that mustache on Lois's driver's license photo. That was art, Stewie.
That was vandalism. I'm talking about using pure mathematics to reconstruct any drawing from spinning circles. Let me walk you through it. Quick refresher. The Fourier series approximates any periodic function as a sum of sines and cosines with period 2 pi. We need to find these coefficients a sub k and b sub k.
Right, I remember this. You multiply by cosine or sine and integrate, orthogonality and all that.
I'm genuinely shocked you retained anything. But here's the catch. When someone draws on a screen, we don't get a nice elementary function. We get discrete samples. A bunch of cursor positions collected over time.
So it's like taking a bunch of snapshots instead of filming a smooth video?
Exactly. We have n evenly spaced samples and we can't compute exact integrals. So we need a workaround. Here's what we do. We can approximate the integral with a Riemann sum over all n samples.
Okay, but how do you actually go from an integral to a sum?
We start with the standard formula for a sub k. 1 over pi, integral from 0 to 2 pi, f of t times cosine kt dt. Now our n samples are evenly spaced around the interval, so sample I maps to the angle 2 pi I over n. And the spacing between samples dt is just 2 pi over n.
So you're replacing the smooth integral with a sum over those sample points?
Exactly. You plug in each sample, multiply f sub I by cosine of 2 pi ki over n, and tack on that dt of 2 pi over n. Then the 1 over pi and the 2 pi over n combine to give you 2 over n. Clean and simple. Here are the final discrete coefficient formulas derived from the DFT. A sub k is 2 over n times the sum of f sub I times cosine. B sub k is the same thing but with sine. Dead simple.
Wait, so that's it? No integrals? Just multiply and add?
Just multiply and add. That's the beauty of going discrete. A computer can do this trivially. Now back to drawing. We collect cursor positions as xy coordinate pairs over time. The ith sample gives us x sub I and y sub I.
So when I'm drawing a star or whatever, you're just recording where my finger is at regular time steps?
Exactly. We treat x of t and y of t as two separate functions. Apply the DFT independently to the x-coordinates and the y-coordinates as a function of time, and you get a parametric form for our approximation. Then, with m terms in the Fourier series, you can reconstruct the drawing. More terms means more detail. 3 terms gives you a rough blob. 40 terms and you're nearly perfect.
Holy crap, that actually works! The more circles you add, the better the picture gets.
Precisely. Sample, transform, and sum. The entire drawing lives inside a handful of Fourier coefficients. Follow for more.